Hello class, today I'm going to talk about Chapter 2. Chapter 2 is really about the atom itself. So what we're going to be looking at is looking at a chemical symbol like copper, that you can find that symbol on the periodic table and you understand where it's located. First of all, there are the copper is called a transition metal, and it's located in the middle of the periodic table. When you look at the symbol, you'll see that it's right next to nickel and zinc, or between nickel and zinc, and there's a number 29 associated with that. Alright, and the number 29 is the atomic number, and the atomic number is equal to the number of protons in the nucleus. So a lot of times the way we write these symbols, here's the chemical symbol copper. A lot of times we'll write a 29 here, and then you'll see another number in the upper left hand corner, something like this number. 65 here is called the mass number, and the mass number is equal to the number of protons plus the number of neutrons in the nucleus. It's always a whole number, always a whole number. You either have a proton and a neutron, or you don't. You can't have a half. So a mass number is equal to the number of protons and neutrons, and it's always a whole number. Now, you generally have to guess on what that number is. Like for copper, if I had to guess, just looking at the mass, which is written below, generally like 63.55, this is called the atomic mass. Make sure you don't confuse that with mass number. We'll talk more about atomic mass later, but the atomic mass is a relative mass to carbon 12, the isotope of carbon that has a mass number of 12, and it's also an average. So this is different. Atomic mass is different than mass number. Again, mass number is number of protons and neutrons in the nucleus. So when we write a symbol like this in complete, this is called an isotopic symbol. An isotopic symbol will always have the mass number, the number of protons, and from that isotopic symbol you should be able to determine the number of protons and neutrons in that particular atom. So I guess before we do that, let's just define what an isotope is. An isotope is an atom that has the same number of protons. And remember, it's the protons that define the element. All copper atoms anywhere in the universe have 29 protons. So the atomic number defines the element. The number of protons define the element. Those are the same thing. But the mass number gives us an indication of what the overall mass of the substance is for that particular isotope. And so if we take 65 minus 29, the mass number minus the atomic number, we get 36. So 36 is the number of neutrons in this isotope of copper. So that's the advantage of an isotopic symbol. If you take the mass number, subtract from it the atomic number, you will get the number of neutrons. Now, for this copper atom to be neutral, you have to have the same number of protons and electrons. So if you've got 29 protons in the nucleus, which defines the copper, for this copper to be neutral, you must also have 29 electrons, which are negatively charged. Alright, let's talk about where does this number come from. Well, when we go anywhere in the universe and we mine copper, we find out that copper comes in two different isotopes. And so one is copper 65, and you can write that. You can either write it like this, copper 65, or you can, if you're going to spell it out, the way it would be written is copper dash 65. And there is another one that is copper 63. All right. These two forms of copper, when we place them in a mass spectrometer that can distinguish between the two masses of these two different atoms, we find out that the copper 63 occurs 69% of the time. 69% of the time for copper, 69.09% of the time. That means if there's only these two isotopes, if we subtract 69.09% from 100%, that means copper 65 must occur 30.91% of the time. Now these percentages have a specific name. They are called the percent relative abundance of the isotopes in the universe, or percent relative abundance is the word that we use to describe that. So when we go to calculate the average atomic mass of copper, what we have to do is take this percentage and change it from a percentage to a number over 100. Remember, that's what a percentage is. It's some number out of 100. And then multiply by the actual mass of copper 65. Now the actual mass of copper 65 is a little less than 65. It's 64.9278. And copper 63 has a mass of 62.93. All right. So what we're going to have here is we're going to multiply the percent relative abundance times the actual mass of the isotope. And we're going to do that for both of these isotopes. And when we finish this and add it together, we have an average. It's a special type of average called a weighted average, but it is an average. So we're going to take 30.91 and divide that by 100. That's going to be 0.3091. And then we're going to multiply that by 64.9278. And we get 20.069. And then do the same thing for the other one. Take 0.6909 times 62.93, and we get 43.48. Add those together. The 43.478 plus 20.069 hit equals, and we get 63.55. Four significant figures. All right, and notice that is the atomic mass up here. So this is called a weighted average. This is how we determine the actual mass of each element on the periodic table. We